Alright guys, I'm going to call this part 2. I am on the second page of the PDF, reviewing linear equations and graphs. And why don't I get a page down here when I do this? There we go. So a linear equation is something that can be written in this, which we talked about as slope-intercept form, and this, which is called standard form, and this is a new one, okay? So any of these are linear equations because they can be written in this form. This one could be 1x plus 0y equals 6. So these are all linear equations, okay? Nonlinear equations are things like you would multiply, have a square root, have an exponent power of 2, absolute value, and we are going to deal with all of these and more throughout this course, but not today. All right, definitions of slope. We already talked about one. You can do the change in y over the change in x. Most of you will say this is a definition of slope. It's really not so much, but the m is slope. It's an equation in slope-intercept form. But now, because we're going to be doing graphing, we are going to refer to it a little bit more as rise over run. Okay, which means we're doing the change up and down and the change across. All right, we could write tilde to the line. We could write y2 minus y1 over x2 minus x1, all kinds of stuff. All right, these are the three forms of a line, and it says up here you must know all of these, okay? And know them and their name. Slope-intercept form, I think you're all going to be really good at. You've already practiced this since probably pre-algebra, and it's real quick to graph those. That's the reason we like that form. Point slope, okay, is super important for calc. You should have seen this in Algebra 1 in geometry, for sure in geometry. Okay, you're going to replace these three numbers, or three things with a number, and it is very easy to create an equation when you're given a point and a slope. That's why it's called point slope. It's not as easy to graph from this form, and you would want to rearrange it. Standard form is really picky. It's a pain in the neck. It's a pretty form because there's no fractions ever, okay? Integers means no fractions or decimal. And it says here a has to be greater than 0. So a has to be positive. B and C can be negative. Only the A has to be positive. Okay? It is easy to graph when we use the intercepts, and that's what I talked about on the previous lesson. The x-intercept, guys, remember, is when y equals 0, and the y-intercept is when x equals 0. All right, moving on, we're going to practice with these. First one is our favorite. It's already in y equals mx plus b form. So the b here tells us we start down at -5, and I am not going to be accurate at all on these. And the slope is 2, or 2 over 1, which tells us that we go up 2 and 1 to the right. So that was 5 down, up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right. Yep, that's not even close to a line. Oh my goodness. I should re-record the video after doing that disaster. Let's just go like this. All right, roughly looks like this. The slope of the line was 2. If you wrote it as 2 over 1, that would be okay too. The x-intercept, we didn't find yet. The y-intercept was this -5 back here. So that was across 0 and down 5. To find the x-intercept, we can go back to the equation. X-intercept means y equals 0. So you'd get 0 equals 2x minus 5. Add 5 over to this side. divide by 2, and we should have 5 halves, or 2.5, as where it would cross here, okay? All right. This one is in, does anybody remember what this is called? It is called point slope form. And it is nice for writing if they give you a point and slope. It is not so nice for graphing. I can pick out the slope here. The slope is 1/2. And I know it goes through the opposite of this and the opposite of this, which would be -2, 1, but that's kind of a hot mess. Let's go ahead and rearrange this because we're going to practice that a lot in a minute. So we're going to distribute over here. 1/2 times 2 would be 1. Add this 1 over here, and in slope-intercept form, we get 1/2 x plus 2. So it starts up here at 2, goes up 1 over 2, up 1 over 2, has a lesser tilt than the last line. Okay, and we need to figure out the intercepts. Well, we found the y-intercept here, okay? The y-intercept was 2, so when we went across 0, we went up 2. Remember, y-intercept means x equals 0. X-intercept means y equals 0. So if I plug that in, I'm actually going to plug it in here. I got to be real careful, guys. If you subtract 2 over the other side, now when you divide by 1/2, you're really multiplying by 2. So 2 times 1/2 is 1x, and over here, 2 times -2 is -4. You can do it on your calculator. You could do -2 divided by 1/2, use your parentheses, you will get -4. So -4, 0 is where, that should make sense. Down 1, back 2, down 1, back 2. We went back 2 twice, so this is -4. All right. Last form is standard form. See how pretty it is? There's no fractions. There's x and y on the same side. It looks all nice. But it is not super useful for finding the slope. It is easy to find intercepts. So if we do that, we put in y equals 0 here to find this one. So we'd have 2x minus 3 times 0 equals 12. Well, 3 times 0 on a good day is 0. So then all we'd need to do is divide by 2, and we'd have x equals 6. For this one down here, do the work over here, we would have x equals 0 for the y-intercept. So we'd have 2 times 0 minus 3y equals 12. Again, 2 times 0 is gone, so we just have to divide by -3. We get y equals -4. So when we put a 0 in here, we got out a -4. So if I said over 6 and up 0, and over 0 and down 4, I'm thinking we could eyeball the slope because the rise for that went up 4 and the run went over 6. So we went up a +4 and to the right a +6. That would be 2/3. Remember, the other way to do this is always to take the good old 2x minus 3y equals 12, subtract 2x over to the other side, -3y equals -2x plus 12, divide everything by -3, y equals 2/3 x, because a negative divided by negative is positive, 12 divided by -3 is -4. We still had a -4, up 2 over 3, up 2 over 3. Okay? I would like you to practice using the intercepts, though. All right. Last part of the, almost the last part. This is just a little special overview. Vertical lines go this way. They cross the x-axis, so they are going to be x equals some kind of number, like -12. I'm making up a number. And they have undefined slope. Horizontal lines run this way. They have no rise, so they have zero slope. And they cross the y-axis somewhere, so you get y equals some kind of a number like 3/5. I'll be just weird, okay? Now, for this example, it says the horizontal line through 2, -4. So if we plot over 2, down 4, and then we do the horizontal line that goes through there, okay? That line has y equals, and where it crosses the y-axis is -4, so we just get y equals -4 from right here. If we were told to do the vertical line through that same point, that is going to cross the x-axis, and it's going to cross the x-axis at 2, so we'll have the equation x equals 2 from right here. All right, so good review of all those special cases. And one more part to this lesson is writing equations of lines. This should all be reviewed from geometry. Parallel and perpendicular slopes are included here. So if two lines are what? Their slopes are equal. What happens when they have exactly the same tilt? Well, they will be parallel. And two lines are perpendicular. Do you remember this symbol is this, perpendicular? Then their slopes, well, to make things perpendicular, if one was going this way, the other one has to go this way. So what has to happen is one is going to have a positive slope and one is going to have a negative. So they're called opposites or negative slopes. And it's got to flip over. If this one's going up 2 and over 3, this one's got to go down 3 and over 2. So they are reciprocals. So a lot of times it'll say negative reciprocals of each other, but they're really opposite signs. Okay? So real quick, given the line y equals 1/4 x minus 6, find a perpendicular line. Well, a perpendicular line would have to flip that over and change the sign. So it would be -4/1 or just -4. A parallel line, remember parallel means they go in exactly the same direction. They're never going to intersect. So that would have to keep this same slope of 1/4. All right, now we're supposed to just practice our slope between 2 points and then make a decision here. The slope of line EF I will do in green. That's these 2 points. Remember, guys, it's changing y on the top and changing x on the bottom. So this comes out to be 3/5. And this guy over here, if we do the same for G and H, -1 minus -6 over 11 minus 8. We get 5/3. Now, are those parallel, perpendicular, or neither? Well, it's a little tricky, but the answer is neither or none because they are both positive, okay? They're reciprocals, but both positive. So if we graphed them, they would both go up and over, so they wouldn't make a 90-degree angle, make some other angle. All right, guys, so number 7, we are going to practice writing this line, and then we're going to practice all of our forms. Oh, doesn't this look exciting? When they give us a slope and a point, it is easiest to start with point-slope form. That form says y minus, then we're going to put the y value in from the point, equals m, which is the slope. And then we're going to put in x minus x1. Okay, be real careful, common mistakes, put the x and the y in the wrong spot or do something crazy like that. We start out y minus the y from our ordered pair over here is -4 equals the slope was 1/3, and then it's x minus the x, which was 3. All right, we can stop right there. We could make this plus positive, and that is point slope form. So that was easy. To get that into slope intercept form, we need to do some craziness with it. So we're going to distribute over here first. 1/3 times -3 would be -1 or -1. And then we're supposed to have the y by itself, because this form says y equals mx plus b. So if we just subtract 4, and be real careful we don't make a silly mistake over here, -1 minus 4 is -5, we're good. Now we have slope intercept form. Finally, we need point slope form. Well, this is where it gets a little tricky, standard form. This is the one that says ax plus by equals c. And standard form, remember, we can have no fractions, and this term has to turn out positive. So, if I subtract the 1/3 x and y have to be on the same side. So I'm going to subtract the 1/3 x over to the other side. It will now say -1/3 x plus y equals -5. All right, I got a hint here. The least common denominator would be 3, yes? Because this is over 1 and this is over 1. I'm going to multiply through by a 3. But if you want to save yourself some time, because we can't have fractions, that's why we're multiplying through. If you want to save yourself some time, you also can't have a negative out front. So I'm going to use as my least common denominator a -3. So when I do -3 times -1 divided by 3, I get a positive 1x, or just x. Don't forget, though, that you are multiplying everything by that -3, and I should have written it like this. So -3 times y is just -3y, and then -3 times -5 divided by 1 would be positive 15. And this is standard form now. No fractions, no decimals, and a positive number here. Greater than 0, sorry. It can be 0 as well, but it has to be positive. All right, moving on. Did I just itch my ear on the video? That's just precious. All right, guys. Now you know how truly weird I am. All right. Equation of the line through 2 points. We must first find the slope, and then we get to pick one of these points. So the slope is change in y over change in x, which turns out to be -15 over -6, which would, if we can make them positive, and then that would be divided by 3, would be 5/2 is our slope. Hope I haven't messed anything up yet. And then we're going to start with point slope form again. So y minus y1 equals mx minus x1. And I'm going to use this point because I'm going to avoid those negatives. So I'm going to make this my x1 and this my y1. So it will be good. Y minus the y1 was 9 equals my slope, and then x minus the x1, which was 2. Okay, you could have picked this point. It would look different here. Okay, it would have been y plus 6 equals 5/2 x plus 4. But when you distributed and solve for y, they would both be the same. It's kind of freaky, but it's true, because this line goes through both of these points. So it was simplified to the same slope intercept. If I stick with this first one and I distribute, I get y minus 9 equals 5/2 x. 5/2 times 2 is 5, and there was a minus, and then I'm going to add 9. I have y equals 5/2 x plus 4. Standard form, remember, is that ax plus by equals c, jobby. So I'm going to subtract this over here. And then I don't want any fractions, so I need to multiply through by the common denominator of 2. If you want to do it in 2 steps, just to show you that that works as well, if I multiply everything by 2, I get negative 5x plus 2y equals 8, but I can't have a negative out front, so then I'd have to change all my signs. Okay, so you definitely could have started by multiplying through by a negative 2 here, just showing you either way. All right, quickly, a couple more examples. This one is slope-intercept form they want us to end up in. But they're giving us a point. Ooh. Anybody know anything about that point? Over 0 and down 8. This is actually the y-intercept, or the b value, if we want to sneak in and use that. Over here, we need parallel to this line, but we don't know what the slope is until we get the y by itself. So 4x minus y equals 6 minus 4x. And then I need to change all the signs, so I get 4x minus 6. So the slope is 4. Parallel. I always write it this way. My parallel slope, or if you are doing a different one, my perpendicular slope, okay, is going to be 4 here. Make a note of that so that you don't forget what you need to do for your slope. Now, a couple ways you could do this one. You could put this point in, y minus negative 8 equals m x minus the x. Or you could just say, I already know the slope is 4x and I know the intercept is negative 8. This would give you the same thing after you did some manipulation. All right, next one, they're trying to be tricky with us. We need standard form at the end. So we got to end up like this. All right, we're supposed to, oh, look what they did. Perpendicular to y equals 3x plus 4 at negative 2, 5. So this is our point. And this is our slope right now is 3, but we want perpendicular. So the perpendicular slope to 3 would be flip it over and change the sign. So our perpendicular slope is going to be negative 1/3. And then they gave us a point of negative 2, 5. So we're going to go point slope y minus 5 equals negative 1/3 x minus negative 2 or plus 2. And we're going to distribute because we're trying to get to standard form. Negative 1/3 times x and negative 1/3 times 2. All right, now, a couple options here. You could add 2/3 to both sides. You could add 5 to both sides. You could move this over here. At some point, standard form means we got to get rid of all the fractions. So I'm going to choose right now to multiply through by a 3 to get rid of all my fractions before I go any further. So it'll be 3y minus 15 equals negative 1x minus 2 after I multiply everything by a 3. All right, now let me see if I can move this down a little bit more. All we have to do now is get x and y on the same side, which will give us x plus 3y equals, and if we add the 15 back over this way, I'm cheating and showing it all at once, I will get negative 2 plus 15 is 13. Okay. If you wanted to check at the end, you could put negative 2, 5 in and make sure it worked. So negative 2 plus 3 times 5 should equal 13. 15 and negative 2 is 5. It checks. Okay, it does go through that point. All right, that would be a good check. All right, last question, and then you will survive day 1 of Precalc. All right, find the perpendicular bisector through these points. Just to think about what this is, go over 2 and up 6, over 10 and down 8. So this is the line we're talking about, and you're supposed to find a line that goes through the midpoint and makes a right angle. This is the equation we're looking for. So it goes through the midpoint. Midpoint, remember, is average. So 2 plus 10 divided by 2. And the y's 6 plus negative 8 divided by 2. You have to add before you divide. You can't do it on your calculator. If you type 2 plus 10 divided by 2, you will get 7, and that is not correct. It should be 12 divided by 2, which is 6. Okay, so be real careful. I should erase that on the notes. It's going to be confusing what that is. All right, so we end up with 12 over 2 is 6, and negative 2 divided by 2 is 1. I hope that's what I got when I did this problem. Because now would not be the time to mess up. Oh, this should be negative 2 divided by 2 is negative 1. How did I know? I should check that. All right. So then we need the slope because we're supposed to do a perpendicular slope. So the slope is change in y, so subtract the y's, over the x's. So this gives me negative 14 over 8, which would reduce to negative 7/4. Is that what I have in my notes? Yes, it is. All right. So the perpendicular slope now, remember, means that we have to flip it over and change the sign. So we get 4/7. Now, there is one golden thing about this question. It says we can leave our answer in point slope form. So the equation would be, we're supposed to use the midpoint for our x and our y and our new slope of 4/7. So y minus negative 1 equals new slope 4/7, x minus 6. Or y plus 1 equals 4/7 x minus 6. And that is point slope form. Now, if we distributed and subtracted the 1 over here, we would get a negative y-intercept, and it's going positive slope, so it does match up with our equation. All right, I'm not even sure I assigned one of those on the homework, but it's a good review of everything we did today. All right, thanks for watching, guys. The final slide I have here reminds you that your assignment on this is on Delta Math. You'll love it. There's hints and short videos you can watch if you have a question on one. Good luck.